This discussion is going to be on the binormal vector. So let's recall the unit tangent vector and the unit normal vector. So what did we know? What was our idea there? The unit tangent vector was velocity divided by speed. And the unit normal vector was the derivative of the unit tangent vector divided by the magnitude of the unit tangent vector. We're going to define the binormal vector. B of t is simply t of t cross n of t. Now, to help us visualize that, let's take a look at an animation. So we have a vector valued function here. Do you see the unit tangent and the unit normal? The unit tangent in this case is the red vector. The unit normal is the green vector, and the binormal is the blue vector. Take the cross product of those. This vector crossed with this, thinking right-hand rule will be pointing in that direction. So let's play this a little bit more. Do you see what's happening? Unit tangent vector is red, unit normal is green, and binormal is blue. So that's what's happening through there. Now, the magnitude of the binormal is the magnitude of t of t cross n of t, which is the magnitude of t of t times the magnitude of n of t times the sine of theta. Well, what is that? Magnitude of t is 1. Magnitude of n of t is 1. T and n are orthogonal, so the angle between them is 90 degrees, or pi over 2, which just gives me 1. So yes, b of t is t of t cross n of t, and the magnitude of b of t is 1. So b of t is called the unit binormal. So let's take a look at an example, and we'll construct t, n, and b. And remember, constructing n can be very challenging. I will try to stick with one that is more reasonable. So let's take a look at r of t, which is 2 cos t, 2 sine t, which is a helix. The velocity, derivative of 2 cos t is negative 2 sine t. Derivative of 2 sine t is 2 cos t. Derivative of t is 1. So the speed, also known as the magnitude of r prime, is the square root of 4 sine squared t plus 4 cos squared t plus 1, which of course is 4 plus 1, or root 5. So what is t of t? T of t is velocity divided by speed, which makes that what? Velocity divided by speed, negative 2 over root 5 sine t, 2 over root 5 cos t, and 1 over root 5. Now, the next thing we've got to do is we've got to find n of t. N of t requires me to get t prime of t first. So what is t prime of t? Negative 2 over root 5 cos t. 2 over root 5 times negative sine t, or negative 2 over root 5 sine t, and 0. So I need t prime of t to get the unit normal, and I need the magnitude of t prime of t. What will that be? We get 4/5 cos squared t plus 4/5 sine squared t plus 0, which is just square root of 4/5, which is of course 2 over root 5. So let's put those together to get n of t. What is n of t? N of t is defined as t prime of t divided by the magnitude of t prime of t, which you'll see how nice this is. Negative 2 over root 5 cos t divided by 2 over root 5 is just negative cos t. Negative 2 over root 5 sine t divided by 2 over root 5 is negative sine t. And 0 divided by anything is just 0. So we need to focus on what? We need to focus on t of t here. We need to focus on n of t there because the binormal is t cross n. So here's t and n. Remember, b of t is t of t cross n of t. So let's go ahead and set up that matrix for b of t. So here we go. Here's our establishment. So then what will b of t be? In the I direction, what's its minor? We cross out the row that I is in and the column that I is in. And we get 2 over root 5 cos t, 1 over root 5, negative sine t, 0. Minus j. Cross out the row that j is in and the column that j is in. Negative 2 over root 5 sine t. One over root 5. Negative cos t, 0. Plus k times, crossing out the k, negative 2 over root 5 sine t, 2 over root 5 cos t, negative cos t, negative sine t. So where does that put us? Plus, minus, plus. In the I direction, what do we get? Zero minus negative, so minus negative is plus positive. So I get 1 over root 5 sine t minus j times 0 minus negative. Again, it'll be plus 1 over root 5 cos t plus k times what? 2 over root 5 sine squared t minus negative, so plus 2 over root 5 sine squared, cos squared t. So 2 over root 5 sine squared t plus 2 over root 5 cos squared t. So what does that give me then for my b of t? B of t in the I direction, it's 1 over root 5 sine t minus j is 1 over root 5 cos t plus k times 2 over root 5 sine squared plus 2 over root 5 cos squared is just 2 over root 5. So my b of t seems to be 1 over root 5 sine t minus 1 over root 5 cos t, comma 2 over root 5. So let's collect our information on t, n, and b and take a look at those vectors, at least for one value. So here's our information. Let's see what we're going to get at pi over 2. So what is t at pi over 2? Sine of pi over 2 is 1. So negative 2 over root 5. Cos of pi over 2 is 0. 1 over root 5. You'll notice the magnitude is still 1. How about n of pi over 2? Cos of pi over 2 is 0. Sine of pi over 2 is 1, hence negative 1, 0. And let's go to b of pi over 2. Sine of pi over 2 is 1, so it'll give me 1 over root 5. Cos of pi over 2 is 0. And 2 over root 5 is 2 over root 5. So the value we need to place this at is what r of pi over 2 is. So let's go back and remember what r was. So r of 2 was 2 cos t, 2 sine t. So at pi over 2, cosine is 0. Pi over 2, sine is 1 times 2 is 2. T is pi over 2. Our value here is pi over 2. So this is going to be our point. And then we're going to put these three vectors in. So let's take a look at that on the 3D grapher. So let's pull up the graph so we can see what it looks like. So here's the 2D version. Notice I have the dot at pi over 2. And here's the 3D version. So can you visualize what t will be? Can you visualize what n will be? Can you visualize what b will be? So again, let's look at the three-dimensional graph, see what we get. So the first vector I want to put on here is t, which is negative 2 over root 5, 0, 1 over root 5 at the point 0, 2, pi over 2. So I've got that vector on and it's red. Now, does it look like it's heading in the same direction as the curve? Can you believe that that's the unit tangent vector? I think so. Now the unit normal vector is 0, negative 1, 0. So we have that 0, negative 1, 0 at the point 0, 2, pi by 2. I'm going to put this on as a blue vector. Now, can you believe that that is, again, orthogonal to the red vector? Is it 90 degrees? It's on the concave side of the curve, so that feels pretty good. And then the last vector that we have is the binormal. We said the binormal was 1 over root 5, 0, 2 over root 5. So let's take a look at that one. So 1 over root 5, 0, 2 over root 5. At that same point, 0, 2, pi by 2. Let's turn that vector on. Now, from this view, they don't all look orthogonal to each other. Let's move it around a little bit. Now, can you believe the red, blue, and black vectors are mutually orthogonal? Looking at it just the right way, I think you can see that. And also think of the right-hand rule that red cross blue equals black is going to give us the binormal vector, all length 1 as well.